Okay, continuing through the lecture, the, the overview of the basic built-in data types. So we went over tuples and lists. And the next interesting data type is the set. This is unordered, so it's not sequenced. You can't access it with these index bracket things. So it's not a sequence. And it's a collection because it's a bunch of items. So the unique property is it could only have objects in it which are unique. So in a list we saw you could have something like this. In a set you can't have 2 3s. So I need to show you through here. In order to create a new set, use curly braces. That gives you a set. So if you do type, it says class set. If you put another 3 here, so it only keeps one of each value. This is useful for sort of filtering out duplicates. There's other set operations that are useful too, like joining sets, like the union and intersection. It works just like a Venn diagram. So if you look at the help for a set, it has an explanation of what it could do. You can add an element to a set, so it's immutable. I mean, it's mutable. You could change a set. Clears a set because you could copy it. So it has all these cool little things, and it's kind of a neat data structure. So basically, syntactically, how all these collections look. So lists look like that. Tuples look like this. Sets look like this. Dictionaries, which are the next data type, are look like this as well, like sets. But the interesting thing about them is the elements of a dictionary they behave slightly different. They have so instead of having a set of like items 1, 2, and 3, dictionaries are similar to a set in that there's these things in it called keys, which must be unique. You can't have 2 of the same key. It's like one key gives you one object or one value. So it's also similar to an array. It's a dictionary. So another ways of calling it are hash maps, but it's basically an associative array. And let me put it this way so it makes more sense. So it's like it initialize a dictionary. Let me clean this up because it's kind of hard to read. I see it's complaining because there's no space. I like PyCharm because it highlights whenever you have not such a clean syntax. So this is what it's doing here. So just like lists, whenever you want to access an element, you give a number. This will behave just like a list. So addictive 1, addictive 2. This will give you the values A, B, and C. In that sense, it's just like it's equivalent to an array in this case. I mean, to a list in this case. So gives you A, B, and C. But let's say we change the keys around here. Basically, you can't use 0 anymore because that's not a key. It'll throw an exception because it'll say this key does not exist. There's no such thing as that key. This gives you a key error. It says this 0 is not a key. What is a key is hello. What is a key is goodbye. Test. So this is one of the most important data structures in programming, and especially in thinking about Python programs and other sort of scripting languages, you'll see this used very frequently. It's the idea of these key value pairs, and what's happening internally is in the same way like a string or let's take the example of a string. A string is in memory in order, and that makes it very quick to access because if you know the size of each element, which is like the size of a letter, like a Unicode character, if you access the 0th one, it'll give you the first letter. If you access the first, it'll give you the second letter. So in memory, it knows if you want to access the first, it just quickly adds the size of the Unicode character in memory and jumps to that memory location. So if you have that number, you could jump to any memory location because it's in order in memory. So if you want the 5th element or the 10th or the 20th in a string, they take the same amount of time to access. Dictionaries use the same trick, but instead what they do is they take something like hello, they make a hash out of it. It's our built-in hash. Let's see if that works. Yeah. So what they do is they're like, okay, this key, first of all, the key has to not be changing. So it has to be an object which is not mutable. Its value can't change. So this immutable key, when I hash it, it gives me, spits out some number. I'm going to use that as the memory address of where to find the value. So internally, this is what it does. And that allows you to create associative arrays, which have essentially instant access to different values based on their key. So it only takes one step to look up any value as long as you have the key. In other data structures, you may have to go through the data structure in order to find the value you want. But dictionaries are very fast because they use this hashing mechanism. So those are the main built-in data structures that are used in Python, and there's a lot we didn't cover, of course, about control flow and making functions and stuff like that, but once you know these data structures, it's much easier to learn the rest. That's pretty much it for this lecture.